I'm Ajay. I would be mainly discussing about the rhythmic aspects of the research that we've been doing. So I mainly work on analysis and characterization of rhythmic structures, which are quite important in the kinds of music we are looking at, and patterns in audio collections essentially. I'm not yet there at patterns. This talk mainly would be on rhythmic structures, so to say. So before we start, we can actually quickly look at some basic background and some terminology, because I'll use this quite often. So most of the rhythm in Indian art music would be mainly Carnatic and Hindustani music. The rhythm revolves around structures called tala, which actually is a time structure for rendition and repetition of melodic phrases, motifs, improvisations, and even phrasing. So a particular tala is shown here. It's just a cycle in time, and then it has the beginning and the end, and then it repeats through. So the beginning of this cycle is the end of the previous cycle. So I've just marked both of them as the same. And in Hindustani music, you have a very similar structure. The beginning of the cycle is quite important, and it's called the sama, or the sum in Hindustani music. And it has musically defined beats. The name beats is not the beats as defined in beat tracking, but these are musically defined, and they are not the foot tapping times as it's usually referred to in the beat tracking MIR literature. And there is a specific Indian name for those kind of beats in Hindustani music. It's called the vibhag. So, and the smallest pulse that we can perceive, and it's well defined, is called an Aksara and a Matra in Hindustani music. I'll refer to Aksara quite often and Sama quite often. So Sama is the beginning of the cycle, Aksara is the smallest pulse that is actually defined. So I can quickly play a video here so that we know exactly what we can expect. So with this, there are two things to observe here. I've marked down the perceptual beats in the audio, and you can actually see a video as it progresses. You can see that the beats are unequal, and then which actually pose a severe problem in most of the state-of-the-art approaches. We can also see the kind of cycles which are pretty long, and then I can track along with that, and then you can just listen to it. So essentially, you saw some annotations. The one corresponded to the beginnings of the cycle. 4 and 6 were the other beats of the same cycle, whereas they were less accentuated. So the aim of essentially the work we are doing is to actually characterize rhythmic patterns. And then when it comes to rhythmic patterns, we have hypothesis. Since there are rhythmic structures underneath, we hypothesize that these patterns are very closely related to the tala, and they are actually separated out by perceivable rhythmic changes. So essentially, in a way, before we actually get to rhythmic patterns, we need to estimate the underlying tala structure which is present, and also estimate the salient rhythmic events, which actually would be the first step which we want to do. So essentially, most of the work so far has been on automatic rhythm annotation, which I fondly call as tala tracking, in line with beat tracking. Essentially to estimate sama, the akshara, and the beats as defined musically, and other rhythmic events which will be useful to us in estimating these patterns. So where does exactly this annotation fit in? So the main rhythm work is, this is the big picture. It's like the kind of work I'll be focusing on during my PhD. Automatic rhythm annotation is actually here, whereas the final aim is to actually do audio segmentation based on these annotations, and then obtain rhythm similarity measures to measure the similarity between two rhythmic patterns, and which can actually give us rhythmic similarity between songs or within the same set of pieces. Finally, all of them would actually go into Dunya, which will be discussed by Alistair very shortly. So first thing we've been doing is to actually annotate some data. So right now we have about 16.5 hours of annotated data, which actually marks down all the samas and the beats and the aksharas, essentially. So the annotated data set actually the Carnatic data set, which is ready right now, is over different talas, and then we have about more than 22,000 Sama annotations so far. It was done by me, which means that it needs to be verified and validated by a professional percussionist, which is being done. And as far as Hindustani collection annotations are being done, Kaustubh has been doing some annotations at IIT Bombay, and we'll be using that for our work here. So one thing which we wanted to do after we immediately started out was to actually do a preliminary check on seeing how the MIR state of the art as it is now today extends to Indian music and Turkish music. So this was a joint work with Andre. So essentially we chose out 2-3 different tasks which might be very important for us in the sense of downbeat estimation, which is an equivalent to Sama estimation. I put all of them in quotes because they are not the exact terms that can be used, and then they are not the way we would define it in Indian music or in the state of the art as they are defined. So what's more important here, apart from the numbers, there are 3 takeaways, things which we got from this paper. Which was that the performance is poor and insufficient, which actually meant that we need to develop some technologies which actually use the kind of structures and then the music information which there, apart from just using the state of the art. The second thing which is more important is that there are engineering definitions for music concepts, and then they did not exist. So some of the time so far has been mainly focused on defining these terms, and then how do we want to define these musical concepts so that we can handle them from an MIR perspective. And the third one, which actually is good for us, is that there is a lot of similarity between rhythmic concepts in Indian and Turkish Makam music, which means that a lot of technologies can be an interplay between the algorithms that we develop for both these music cultures. So next I'll actually move on to some basic tasks and then discuss some challenges and some basic results I've been getting so far. One of the main things is that as soon as we start with rhythm is to actually if we can get the onsets in the piece. It so turns out that for Indian music at least, we have dedicated pitched percussion instruments always accompanying music, which means that onset detection can be quite easy compared to other kinds of music. So here we can see I've marked down, this is the low frequency components, and then we can actually get most of the percussive onsets very easily. It's pretty easy. But then again, as soon as we move on to the next level, and when we say, okay, let's track beats are not equal in this piece at least, as we heard, and then most of the beat trackers don't account for this kind of they are not designed to track unequal beats at all. Though there have been certain approaches in which you can give weights to each of the beats which have been detected, but then most of the time it doesn't really work. So regarding my work especially, I've been focusing mainly on getting the Aksara pulse period, which is quite useful because with that I can define the length of the rhythmic cycles, and then I can finally get to the point wherein I can track the samas. So this is based on the tempogram. The tempogram is just time over BPM. The BPM there is not very well defined. I would call it the number of Aksara pulses per minute because that's what I'm tracking here. So, and we can, in a way, we can track this Aksara pulse. As we can see that it's not stable, which means that the tempo as perceived can change over time, and then that can be quite significant when it comes to tracking the Sama periods. So once we have the Aksara pulse, essentially we can move on to getting the Sama, which is the beginning of the cycles, and in which we can see that there are certain descriptors which we can extract. In this case, it is the novelty function, which is computed from a feature self-similarity matrix. We can see there are certain indications towards where the Sama can occur. The ones there correspond to the Sama, and there are quite a lot of indicators which can be used to say where the Sama occurred. But at the same time, they are not completely indicative. So Sama points are, as I said, characterized by certain rhythmic, timbral, and melodic changes. And then, but then it's not exactly specific in the sense of not at each sama can I find any of these, or it's not also necessary that I will be able to find that there's a melodic change at a particular sama. Which means that there are a lot of indicators, but there are also a lot of false positives. Which means, in a way, that we need to bring in some prior information in the terms of which thala it is, and then what is the kind of rhythmic structure that we are actually looking for in the signal before we actually can start predicting and then saying these are the sama points. So the kind of work so far has been to use such a novelty function and then use the peaks, the candidate peaks, which we saw from the previous slide here, into classifying them into candidates, taking their salience based on the peak height, and transition weights based on the period that we have estimated of the cycle from the pulse that we estimated from the Aksara. So this is a formulation just to actually select the set of peaks which actually ensure a continuity and also ensure that there's a salience. This can be seen as these actually take these peaks and then they sum up their salience, and then there's a transition cost for each of those peaks that have been picked. And then if we solve this problem either by dynamic programming or otherwise, we'll be able to get a set of peaks. Though the results of this are not very, there's still need a lot of improvement from the set of the different kinds of descriptors that we are looking at. So finally, what I've been mainly focusing, what I'll be doing for quite some time now would be to develop a general framework for rhythmic event estimation, and these events could be the samas or the beats or any other event which can be very well defined, and for any of the music cultures that we are looking at. So this framework would enable us to develop algorithms which can be used in a wide variety of musical cultures and for estimating different events. And eventually we'll use this framework and then kind of mainly adapt it to each of the music cultures to develop specific algorithms for each of the estimating events. And then from the events we'll move on to rhythmic patterns. Yes, that's all I have from here.